Hello. Hi everyone. Welcome to Kuchetti's Technology. Thank you for watching my channel. So if you are watching first time, please subscribe my channel. Thank you. So today our topic is the difference between anonymous inner class and lambda expressions. So before discussing today's topic, in last session already we covered some of the points same like and the difference between anonymous inner class and lambda expressions. Let's revise those points and we'll continue this today's topic, some other differences. Okay, let's check. Let's revise. So in the last session we discussed, right, some of the points, so first point is there are totally 4 points we covered in the last session. So first point, anonymous inner class can extend concrete class. Means by using anonymous inner class we can write, so for concrete classes also we can write anonymous inner classes, but we cannot write lambda expressions for the concrete class. That is the first point we discussed, and we seen some example for related to this. And second example, for for abstract classes we can write anonymous inner classes, but we cannot write lambda expressions for abstract classes. That is second point. We have seen the example. So if you more information, right, related to this, you can refer last, you can see last video, the previous video. So now third point, for non-functional interfaces, we can write anonymous inner classes. But here non-functional interfaces means what? If a interface, it contains more than one abstract methods, that interface we can tell non-functional interface. Functional interface means what? It contains only one abstract method. Non-functional interface means it contains more than one abstract method. Okay, for non-functional interface we can write anonymous inner classes, but for functional interfaces we can write, for functional interface it has only one abstract method. Okay, so this is about that. For non-functional interface we can write what? Anonymous inner class, but for non-functional interfaces we cannot write lambda expressions. So fourth point, for functional interfaces also we can write anonymous inner classes, and for functional interfaces only we can write lambda expressions. So only this case lambda expression will replace with anonymous inner class. So coding wise and functionality wise, memory wise, those are still different. But in this case, without using anonymous inner class, we can write lambda expressions in the case of functional interface implementation. So now our topic will continue the remaining differences, right? So we'll see thoroughly all the differences and with practically. Okay, today, so one by one point we'll discuss the differences and we'll see practically. So it is inner class without a name. Anonymous inner class is a inner class without a name. Lambda expression, it is a function without a name. Anonymous inner class can extend concrete class, abstract class, and non-functional interface. In last session already we discussed, and just a few minutes back we discussed about these points. So no need to discuss it again. So this also same. We cannot write lambda expressions for a concrete class, abstract class, and non-functional interface. It can implement functional interface. For functional interfaces also we can write lambda expressions. Only for functional interfaces only we can write lambda expressions. Fourth point, anonymous inner class can be instantiated. So whenever we are writing, right, if we observe or not, we write new keyword. We write new keyword for while writing anonymous inner class, we write new keywords. So let's see one example about anonymous inner class. I have taken one interface. It contains my M1 method. I'm writing for this interface anonymous inner class. We write like this, right? We write likewise new. So whenever we are writing new keyword, whenever we write new keyword, it is instantiated, means providing the memory to the object. So anonymous inner class can be instantiated, but in the case of lambda expression cannot be instantiated. In the fifth point, in anonymous inner class, this always refers current anonymous inner class object. In the case of anonymous inner class, this keyword always refers anonymous inner class object. But in the case of lambda expression, this always refers current outer class object. Okay, we have to see for this point practically. Let's see. Let's go and check out the point. So for that, I have taken one interface, and I have taken at class level one instance variable with x equal to 10. So in that class, in this anonymous class, I have taken a method. I'm trying to create anonymous inner class for this interface. Interface one, new interface. So here I opened, here closed. So in its opening and closing, here anonymous inner class implementation finished from 10 to 15. So at 10th line, anonymous inner class implementation started, and at 15th, it ended. So after that, right, int x equal to 20. So you may get doubt here, int x equal 20, and here int x equal to 20, here int x equal to 10, here int x equal to 20. Why I have taken? So the point is, in anonymous inner classes, this keyword always refers inside this. So if I take same variable names, now we can get clarity, which value it is printing. We can decide which one it is taking first preference. That's why I have taken same variable names. So here public void amount, I have provided implementation for this method. So now I'm printing this dot x. Okay, now I'm calling, once anonymous inner class finished, I'm calling with this anonymous inner class object and m1 method. So I have created here anonymous, new anonymous dot. For calling non-static method, I have created object and called the method. Okay, now let's compile it. CLSCR. It's not working. Let me open freshly. So I opened command prompt, Java C space, Java C space test dot anonymous dot Java, right? Anonymous dot Java. So created. So we, before executing the file, so in the case of anonymous inner class, this keyword always refers current anonymous inner class object variables. First preference to this, whatever we are taking, first preference this. Afterwards, if it is not there here, it will take afterwards outer side class. So now here I'm taking this dot x, means it will print expected output is this 20. Java C, Java space, anonymous, Java space anonymous. So 20, correct? So in the case of same lambda also say same, likewise I implemented. I have taken interface one, class lambda, int x equal 20. So public void test. For writing lambda expression, already we know we don't write anything here. Lambda, while writing lambda expression, we should not take care about modifier, return name, and method name. We won't write while writing lambda expression. Already, if you see the first classes, that is the point we discussed. So we take this only this parenthesis and lambda expression and kept open bracket and close bracket. So for in the lambda, while writing lambda expression, body contains only one line of the statement. Putting this parenthesis symbol is optional. So here we have two statements. That's why it's mandatory to put this parenthesis symbol. So now I have written lambda expression for this interface, and I'm printing this dot x. So as per my statement, it first preference to this keyword, first preference to outer side class. So it has to print instead of printing 20. So it is local variable. In the case of lambda expression, it is local variable, not a non-static variable. So this dot x means it will print this. It will take this, not inside one. That is the expecting. Our output should come now 20, not 10. Sorry, 10. Outer side class. I'm telling. Yeah, it is 10, not 20. Correct, boss. Now Java C. Java C space lambda dot Java. Just a second. Yeah. What I saved, boss. What I saved. Okay. Extension not saved. Yeah. Save as lambda dot Java. Okay. Now it will be executed. Compiled first. Afterwards, Java space lambda. Now 10, right? Not inside one, outer side it's printed. So I think my points covered, right? So wherever we discuss it in anonymous inner class, this always refers current anonymous inner class object. In the case of anonymous inner class, I showed that point. So in the case of lambda expression, this always refers current outer class object. So in anonymous inner class, we can declare instance variables. So whatever we are declaring, right, in the case of anonymous inner class, these are the instance variables, not the local variables. In the case of anonymous inner class, these are the instance variables, not local variables. But in the case of lambda expressions, these are the local variables, not instance variables. That is the point. That is the point. In the anonymous inner class, we can declare instance variables. But in the case of lambda expression, we can declare local variables. So 7th point. For anonymous inner class, separate dot class file will be created. For anonymous inner class, separate dot class file will be created. But in the case of lambda expressions, separate dot class file won't be created. So let's see. So I will remove now all the dot class files, boss. All the dot class files. Shift delete. So now we have this test also not needed now, not required. So now I'm going to compile again anonymous. So for anonymous, as per the statement in anonymous inner class, how many classes we have? Interface is a for interface dot class file, however created, right? So we have to see, yeah, for interface dot class file, however it will be created. For anonymous, it is a class, however it will be created. What about anonymous inner class? For this object will be created or not? So here object will be created. So here now Java C space anonymous. So let's check out. Let's check out now. See, 1, so 1, 2, 3, 3 dot class files created. Na? So anonymous, it is a class, it is inner class, another dot class file is created. So now we'll remove these all things, right? Lambda, okay, we'll not get any confusion. It is different name. Na? Now we'll compile it. So now see lambda expression, how many dot class file will be created. So it has to create for lambda 1 and for interface 1. So interface is common now for both of the classes. I will remove these dot class files for getting the clarification about my point. So now, I would like to compile a lambda expression. Java C space lambda.java. So here only two dot class files will be created. So proved, right? This point proved, hence proved, right? Okay, so dot class file for anonymous inner class, separate dot class file will be created. In the case of lambda expression, separate dot class file won't be created. Okay, now, so for anonymous inner classes, memory where it will be created, in the heap area, memory will be created. So in the case of lambda expression, memory will be created at method area. So in the case of anonymous inner class, in the method level local variables, we cannot change. We cannot change or update. So in the here, right, in this point, sorry, just a second. So in this point, both are the same. Both are the same. Both are the same. No difference. Why? Because so in the case of anonymous inner class, method level local variables we cannot change or we cannot update. So those values, right? Both those values, final or effectively final. So in the case of anonymous inner class, in the method level local variables, we cannot change or update. Those method level variables, right, will be final or effectively final. In the case of lambda expressions, also same. So let's prove that point. Why I'm this same these 2 points? Why I'm telling actually in the lambda expression these are main important. This point is main important. That's why even this here anonymous inner class and lambda expression it is same point. That's why even though it is same point, I'm bringing here this point. So why? Because this point very important in the lambda expression. So let me show you first. It is anonymous inner class point. So here at method level, right? In the method, oh yeah, in the method, yeah, here test method is there, no? Here I'm taking into I equal to, I'm taking into I equal to 20 something. Into I equal to 20, I'm taking. So we can write if you want to refer them, no? I'm removing this. This is not required now. So I want to print these X and Y values. I can easily print, not an issue. Not an issue, not an issue at all. I can print. So now I'm removing this keyword I'm removing. So now I can refer and print, not an issue. But what is the issue? Let me tell you. Java C, Java space, Java space anonymous. See 1020. Not an issue. But when the issue will come, if whenever we are trying to change the value, we can change X value, not an issue. X equal to 10 is there. I am updating it to 100. Outer side, in the outer side class, we can change. Outer side variable value, we can change. But at local variable, these values are, whenever we declare at method, these values are local. By whenever we are using in the anonymous inner class, whenever we are trying to update, we'll get exception. They're final. These values, whether we put or not put, these are final or effectively final. So now I'm trying to put here y equal to 200. Y equal to 200. So now see what exception we'll get. local variables referenced from in inner class must be final or effectively final. Okay, this point is okay. So local variables we cannot change. We can use and just we can show wherever we want. We can use them, but we cannot try to update. So now why I'm putting comment. Just I'm trying to change to 100, right? This X value I'm trying to change 100. 10 is there. I'm trying to update X value. So now let's see. Let's see now this point, same point. Now, no, not an issue, right? X is updated to 100. So the same point, right? Will implement at lambda expression. Same point here also same. So here X equal to 10. So I'm removing this. In the method I'm taking into y equal to 20. Into y equal to 20. I'm removing this variable not needed. So just I'm putting here xy, x and y. Okay, now I'll save this file and compile it and just compile. It is lambda, not a problem, right? Just we are using the variables, whatever we declare it, right? We are using them, not an issue. 10, 20 printed at the outer class 10, 20. It's printed, not an issue. Now what I do, I am right after printing. So now I want to update y value as 200, y equal to 200, boss. Now what exception will get? See, whatever exception occurred for anonymous inner class, same exception. See, the local variables referred from lambda expression. There is inner class, but here lambda expression. The local variables referenced from lambda expression must be final or effectively final. Got it? So this is the main thing. So once more we'll revise. It is anonymous inner class without a name. It is a function without a name. Anonymous inner class can extend a concrete class, at abstract class and non-functional interface. Lambda expression, it cannot it can implement functional interface. It can only implement functional interface. Anonymous inner class can be instantiated. It cannot be instantiated. This keyword refers only anonymous inner class object. It is lambda expression outer side class object. In anonymous inner class can declare an instance variables. So whatever anonymous inner class, whatever we are using those variables, we declare those variables will be instance variables. But in the case of lambda expression, those variables treated as local variables. For an anonymous inner class, separate dot class file will be created. For lambda expression, separate dot class file won't be created. For anonymous inner class, memory will be created at heap area. For lambda expressions, memory will be created at method area. So in the case of anonymous inner class, so if you are trying to update method level variable values, we'll get the method level variable inner class variables. Those are final or effectively final. In the case of lambda expressions, also local variables. I mean method level variables. We can use wherever we want, and we can write business lesson, but we cannot try to update those values. So that's it today discussion. So if you have any doubts, right, you can comment. You can comment. I will reply to that comment. Thank you everyone. Thank you very much.